All right, folks, so now this lab is actually about transformers, okay? Not the kind of transformers you see in the movies, but I wish it was. But it's about transformers that we use to step up or down voltage and current in relative to the total power that is transferred. And we talked about this in class, but I wanted to show you guys what actually in the lab you would have done with regards to that. Now here, this is not exactly a transformer, but this is a solenoid that you use to control this valve electronically, okay, or electromechanically. So this is an electromechanical device, and I couldn't find a transformer that was opened up to show you guys. This was the closest thing in the lab that I could find to a transformer, and similar to what you would see, there's a coil that's wound around a core, and then there's an area to drive that flux, and when this coil is actuated, this pulls in this metal piece in, and then depending on how the spring load is set up, you could even make it open or close the valve when you apply a voltage. Okay, so this is something very similar to a transformer. And then if you look at a machine, soon we'll study that electric motors are another type of a transformer, and this is the rotor of a DC motor, and you can see the coils that are inside it, inside that rotor part of it. Okay, so this is another type of a transformer, just to get an idea of what they would look like. Now in the lab, we have this little closed box which contains a transformer, okay, and it can be configured in many different ways. We have a couple of primary configuration types. We have a couple of secondary configuration types. You can see the primary and the secondary here, right? And by turning on different switches, we can effectively change number of turns on the primary and the secondary side. Okay, and if you remember from class, this symbol indicates the core that is connecting the primary to the secondary. Okay, and now in the experimental setup, we have a variac here. This is a variac. Oh, this is a. Oh, it's not good. So we have a variac here. What is? I see what's going on. Okay, never mind. I'm running out of cable length. So we have a variac, and what a variac does is it's actually a transformer inside it. By changing the number of turns, we know that we can change the voltage applied. Okay, so by rotating this little knob, you can see that I am changing the voltage, RMS voltage that I see on the Valhalla. Okay, I'm changing the voltage. So that allows me to control the AC voltage that is going into the transformer. Okay, I have set this up according to the handout for the transformer lab, and it's supplying the voltage to the transformer, and then transformer secondary. There is no primary, there's no direct connection, right? You can see that there is no direct connection. It is only connected through the core magnetically, and that secondary is connected to the second Valhalla and then into our load box. Okay. Now, first of all, what I'm going to show you guys is how this transformer is working, basically. Okay, so let's see. So you can see that there is 14 volts on the primary side, and then we have 7 volts RMS on the secondary side. Okay, both measurements are RMS, and I'm basically going to approximately double the voltage. Okay, so I'm increasing the supplied voltage. What was that? We had 14, right? say 28. Okay, so I double the voltage and let's see what's happening. We have doubled the output. Okay, so now there's a direct connection from input to the output through that magnetic circuit. Of course, there are some efficiency factors that's involved and certain losses that are due to certain magnetic feature or phenomena that we already discussed that will affect the losses. Okay. So now in the experiment you are going to do 3 experiments. First one is the short circuit test. Short circuit test is basically this primary, the secondary side. Primary side is connected to the variac. The secondary side is, so this is the secondary output. You will short circuit this secondary output. Okay, and then we'll apply a very small amount of voltage to measure that short circuit current. Okay, and by now hopefully you have learned what that short circuit test captures in the transformer core. It captures a certain path within that magnetic circuit, and then the second test is we are going to open circuit and measure the current going through at a voltage. Okay, and that captures another part that was not captured by the short circuit test. Okay, so that's the first part of the experiment. I won't try to do that right now. Okay, I'm just trying to explain to you what we do, and then in order to do the load test, what we will do is we will set the variac to a certain voltage. Okay, from this end we will set the variac to a certain voltage, and then we are going to go onto the secondary side load, and we will add one load at a time. Okay, and then if we go into our current measurement, okay, see we are adding, so let's see, there you go. So now so there's no load, right? No current flowing through our load, or maybe very tiny amount of current, and that's why our power shows as 0. Now we are adding load. Okay, and now we can see there's current flowing on the secondary side, right? We can see 0.2, and we can also see the same on the primary side. Okay, on the primary side, let's see what happens. So if you look at current, see, we see some amount of current. Okay, you can see some amount of current. Let me switch. There you go. See, you can see a current in the primary side, and we can also see some power dissipation in the primary side as well. Okay, all right. That's a little bit weird though. No, it's okay. So in terms of power, we have 1 watt coming in, we have 0.4 watts coming out. Okay, but I think the current measurement is quite off here, because yeah, it's okay. There's more current coming in than what's being delivered to the load. Okay, and now I'll show you. So as we add load, our current goes up, power goes up, and so is our input power. Okay, input power goes up. So likewise, what you will do is you will record all the currents for different load settings, and with that information now you can draw how the transformer responds to different loads, because now we are basically increasing the secondary side current, and we are trying to look at what's happening to that input side current, which contains the losses as well as the efficiency. Basically they are related, right? So it's going to affect the losses as we increase current, which will impact efficiency. Okay, And we can even see the effect of saturation occurring as we increase the load. Okay. All right. So hopefully this was good enough information for you to get an idea of the experimental setup. What I'll do is I'll include all the data for you to analyze, and you can come up with the transformer parameters and write up your report based on these results. Okay. All right. So that's it for this lab experiment. Thank you.